Hello everyone and welcome back to the channel. So in this video we're gonna work on image textures more, and we're gonna build this kind of cool page. Right now it doesn't look cool obviously because these look just like simple image elements to you, but in fact these are image textures that have been mapped on plane geometries, and when I hover over you can achieve some kind of cool and hover effect like this, which you wouldn't be able to do with just simple HTML JavaScript. And these are not image elements, but I'll show you how you can achieve this kind of thing, and then from there you can actually take it to the next level. This is just one example of hover effect that I'm showing you. I'm just like playing with fragment shaders here. You can play with vertex shader and do much more. You can do a lot of things even on a scroll, but right now I'm keeping it simple and only doing it for just playing, manipulating the fragments right now. So I'm very excited about this. This is actually something that you can use in your website creation. It's not just like a tutorial that I'm showing you, hey, do this. You can actually use this, for example, for your portfolio showcase or any images that you have in throughout your website. You can do some kind of similar things and achieve similar hover effects or anything you want to do. So like I said, I'm very excited about it, and let's get started. Alright, before we get started, quick look at the state of our code right now. This is the POG file markup for the Three.js page. So I basically have a Three.js class wrapper, and then I have a few sections, like 5 or 6 sections. And these, the first one is just some text, and then I have all these 1, 2, 3, 4, 5 sections with each one image, and I have like just images from unsplash.com, so nothing special there. And what I have for my styling, I have like for each of those sections I've done a little bit of styling over here. Again, nothing special. We'll come back to the opacity and we'll play with this in a little while. So I have the image opacity set as 1 right now, and then lastly in our index.js file under app canvas Three.js, where all the Three.js stuff happens, I have just my Three.js canvas, width and height, my scene, camera, and my render. Nothing again special there, similar to what we've always had. And so if we take a quick look at the localhost 3000 right now, you can see I have all these images and my little text up here. So what we're gonna do, we're gonna replace these images with textures that we put on our WebGL, our Three.js scene. So let's get to that. Alright, first thing we're gonna do here in our index.js file is we're gonna call a function add texture images, and that's where we're gonna add all those textures. And next here I'm just defining my function outside my constructor, and what I'm gonna do, I'm gonna grab all those images. As you remember, I have sections with images here, and they're all under my Three.js wrapper over here. So that's how we get them using query selector all. And let's console log them, and quick look over here. We just want to make sure we have all our 5 images. Yeah, all of them are here. We need to do go through a loop of these images. So what I'm gonna do is I'm gonna use the spread operator. So now we can loop through these images, basically just doing a map, in fact, not looping, just kind of like a map function, because we want to return something as this image data over here. So I'm gonna map all these images and we'll see what we will be returning later on. Just to see all the images are still showing up right, I'm console logging them over here. Let's take a quick look again, and we have all these images. Now what we want to show as the textures on our plane geometry that we're gonna use is the image source. So that's basically what we will be grabbing from these images. So let's do that. I have my texture loader, 3 texture loader, and I'm gonna load the source of each image, which we can get using the get attribute. This is JavaScript, so nothing special there. And then I will define a common geometry for all my textures, my images, and then for them we will be having different materials. So the geometry over here, just a plain buffer geometry with width and height of 1, doesn't really matter. We'll be scaling these to match the image size, the actual image size that we have in our HTML. So 1 and 1 should be enough, good enough. And for material here, I'm using for now a mesh basic material, and we've seen this before, we've done this before. You can go check out my previous videos. We can use that texture as the map and basically map that texture on our geometry. Now I'm using both sides. I want to be able to see. It doesn't matter, front side should be enough, but just in case I'm doing double side. And then finally I'm putting these together, my geometry and the material. Again, like the material is gonna change since and it's coming from the texture, which is the source of each image. So if I save this, and don't forget to add the image meshes, the meshes to your scene, of course, otherwise you wouldn't see them. So I see my original images here. If I scroll, you'll see this in the background pop up. So what I'm gonna do, in fact, let's go do it over here in my Three.js. I'm just going to bring down the opacity to, let's say, 0.3, so we can see what's happening in the Three.js scene rather than in our HTML. So you can see, like, I have all my plane geometries actually in the 0, 0 location. This is 0, 0, and they're like all in the same place and with the same x and y width and height, because we have 1, 1 for all of them. So they're basically like stacked on top of each other. What we need to do is to place each image where it belongs, which is basically getting the coordinates of each image in our DOM, and then map that to our Three.js scene coordinates. So for example, if we have like the top location of this image, we have the width of it, height of it, and then maybe the left position, we can kind of map our Three.js plane into the exact location where our HTML images are. To do that, we can actually use the get bounding client rect function for each image, and this is gonna give us all the information about the image width, height, and everything. So I'm recording everything inside this boundaries variable, and console logging it. So let's take a quick look what we get for each image, and keep in mind this is still our HTML images. So As you see over here, for example, for this first image, again, HTML image, I have my bottom, right, left, right, height, left, right, top, and width. And if you look at all these, as you can see in the images, you should see the left position and the width of all of them should be the same. You can see it's left 488, 488, 488, 488, 488. So they're all the same, and then width of them are also 500. All of them are the same. The height is different, and the top position is also different. Another thing to note is that top in our HTML is being counted from basically like this top left corner, so that's our 0, 0. And in our 3JS scene, 0, 0 is like in the middle of this screen right here. So that's something we need to keep in mind, and we're gonna take that into account later on when we do some position updating. But right now, so this shows my top is 120, so that's 120 pixel from the top of viewport, and the next one we expect to be much bigger, 765, so that's the top of this. And if we do a little bit of math, it's got 625 of height plus 120, it's like 745 plus a little bit of padding, so that makes sense, like 20 pixels of padding, and then 765 will be the next one, and so on and so forth. So these are the numbers that we get from this get bounding client reg. The next thing we want to do is kind of like apply a scale to our meshes, because right now as we saw over here, all our geometries are 1-on-1, so we want to scale them based on the width and height of each of the images. So that's what we are doing here. We are still inside this map over here, this map function. So we're doing the scaling for each of the images one by one as we go through this kind of like map function for each image and separately. So if I save it right now, let's take a quick look. So you see that actually it seems like that image is like super large back there, and you can just see like this first image kinda. If you compare, it seems like that's what's happening. The next thing we're gonna do, we're not done, we need to scale. After scaling, we need to also position these images in the location that they are. In order to do that, we first need to fix our field of view for our camera, because right now my camera is located at position Z of 10, and then I have 70-degree field of view, which if we want to have the exact height of our texture image, basically our geometry in the scene compared to our image in the HTML, we need to make a little bit of fixes here, adjustments here, and I want to show you this little quick image over here. What you see here is our, let's say our camera is right over here, and we're looking at this object, and then we know this is, for example, our far, this is our near, and then this is the camera Z position basically from the element, from the object. And then far and near, we know this is near, this is far, this is our aspect ratio, and then this is our field of view. If you don't know what these are, again, go back and check some of my previous videos. You'll find good information there. Now, what I want to know is, hey, what should my FOV, my field of view, be if I want to have a realistic height for my elements, for my objects in the scene compared to my element in HTML. So in order to calculate this is half of FOV. If like I draw a line that is like goes through half of the height of my object. So what we can do is we do a little bit of math over here. Tangent of this FOV over 2 is gonna be height over 2 divided by z. So that's gonna give us tangent, and then so with that we can get FOV over 2 and then multiply it by 2, and then finally we need that's gonna give us a radians. This FOV in radians, we need to convert that to degrees, so multiply it by 180 over pi. So that was just a quick explanation. Let's take a quick look again over here. So if we do a tan of that height over 2 multiplied by z, which is 10, we can then get our FOV over 2. Okay, FOV over 2, the tangent is equal to height over 2 divided by z. So if we do a tan, it's gonna give us the FOV by 2, then multiply by 2, it's gonna be our FOV right here. And since that's gonna be in radians, math.atan, it's gonna return the arctangent in radians. So we need to convert it to degrees because our FOV needs to be in degrees, and this is how we do it. Multiply it by 180 over math.pi. So this is one step that we need to take. We are not done yet, so if we look back, still we're gonna see the same thing. We just like fixed one problem. There are a couple more problems that we need to fix. In order to do that, I'm gonna finally return what I need from this map function over here. So I'm gonna return the image itself, the mesh, and width, height, top and left of each image. And remember, these are the boundaries, basically properties. So this is gonna be for the actual image, not for the geometry, the Three.js object. So we're returning all these. I'm going to update the positions now, and this has to happen in our update function, which is where we are doing the request animation frame. If we look at our boilerplate here, the index.js right under app, our update function has our request animation frame. So that's happening in every frame. So we want to update this position inside that function because eventually we will be scrolling through the page and also resizing everything. So we need to make sure that this position is always updated. So I'm gonna call that function in this update function, and then I will be defining it over here. Now this is something that we need to also talk a little bit about. What I'm doing here for each of the image data that I got from the this map function over here. Remember, it's returning all these information for each of those images. I will be looping through them, and then for the image mesh, which was actually our object where we are mapping our textures on, I'm going to position those meshes correctly. So I have position X and Y, and remember I said in our DOM element HTML, our center is up top left here. So we have like everything starting from up here going down, y increases, and then x from left to right increases. But for our scene, for 3JS scene, everything starts from the middle. So this is 0, 0 as opposed to up here, which was 0, 0. So if I want to kind of map the position of my 3JS object to where they would be kind of like on the scene, or vice versa, for the x we need to know the left of image, and then we'll have to subtract half of our viewport width, well, canvas. This width is our canvas width, and then we need to add half of our image, because like the canvas width is like this width from here to here, which is right now our viewport width. So if I subtract my left, which is right here, so my left minus half of that, and then we need to add half of this image to the width of image, so that we can get the actual x position of our mesh. And then for y, similar concept with height this time, and also remember y will increase when we go down from top to bottom in our viewport HTML, but in 3JS it goes up from like bottom to up. So like this is the positive direction from bottom to up, HTML, and vice versa. So that's why we have the negative image at top plus the height over 2, and then that's the canvas height over 2 minus the image height over 2. So that's that. That's another step. And we still are not done, because we need to do another round of positioning everything correctly. So let's go ahead and do that. This is gonna be needed in the resize as well. So in my onResize, which is my window resize listener, I'm going to check if I have my image data, if the image data, everything is loaded, I have them. I want to go through all of them, and then what I'm doing here is assigning the top, height, left, width of my image data using the get bounding client rect of the actual images. These are the actual images of my HTML, like my HTML image elements, and this is my 3JS objects, which I have mapped my textures on. So those top, height, left, and width, we assign them, and then finally we make sure also scale our image mesh to the width and height of each image. And like I said, this is gonna be needed in our resize, in our window resize. We also need to do it originally, so I'm going to add that same onResize function over here. So in the first load, we also want to see that. And now if we take a quick look over here, we should see some changes, and yes, we see now. You can see that our HTML elements are moving as I scroll, but the 3JS geometries are not moving. And I can change the opacity to 0 over here, so we got rid of the images, the HTML images, and now you can see like this doesn't move. So we need to fix that. We need to somehow bring in the scroll position in our y calculation, because x is constant, the x's are gonna be the same, the y of these images should change. And to do that, you could kind of hijack the native browser scroller, but we're going to make it a little bit simpler, so I'm going to use the scroll trigger from GSAP. It's gonna be very easy. Originally our scroll position is gonna be 0, so I'm storing my scroll position inside this scroll variable, and then still inside my constructor, using the scroll trigger create function over here, I'm going to grab my Three.js element, which was the whole scrollable part of the page, basically with all the images. That's my trigger, and from where like the start is gonna be top, and the top of viewport, it's the top of that element, all the way to where the bottom of viewport hits the bottom of that element. So this is gonna cover the whole element. And what I get from here, if I store it as my scroll st variable here, I will be able to add an event listener to my document, a scroll event listener, and as I scroll, I can get the scroll position using the .scroll basically function, the scroll function of scroll trigger, and then I'll assign that to my variable where I'm keeping track of scroll. So once we do that, the only thing we need to do is again to update the Y position of each image. So I'm gonna just add the scroll to this right here at the beginning. If I save and go back here, hopefully when we scroll this time, as you can see, our WebGL Three.js geometries also are moving, and to make sure that's happening, let's grab, like if I hover over this, first of all we can see like everything is moving. If I change the opacity to 0, you can see they're still there, so they are still there. I'm gonna go change the opacity to 0 over here so that they are set to 0. And then now these are not our HTML images, these are our WebGL geometries where I have mapped the textures onto. So now we went through like, I don't know, 30 minutes of video to get to this point, which we were actually in the beginning of the video. So why the hell did we do all this? The reason is that now we can do a lot of things with these images, including some cool hover effects that we're gonna take a look in the next few minutes. So let's get to that and see what cool things we can do with it. So in order to be able to do some cool, for example, hover effect that we're going to work on, we need to convert what we have here as mesh basic material into shader material so that we can play with the vertices, with the fragments of the image, colors, things like that. And so what I'm gonna do here, I'm just gonna comment this material out, and I'm going to define my shader material, and we can pass the texture as a uniform to our GLSL files. I have my files over here, you can see under this shaders folder, so I need to import them over here as well. My vertex file is just a basic vertex file. I have the position here, and it's basically what we had in my intro to shaders video, so I'll put a link to that, go check that out. And that's all we need for the vertex file. We're gonna do most of manipulation in the fragment file. So if we go there, in order to bring the textures and like basically put them on top of our geometry, we have also done this. I have a video where we showed some image transition effects, so go check that out. In that video I also explained how you can use shaders, basically fragment your fragment GLSO file to use the texture 2D to map your texture on your geometry. And this is how you do it using the UV and U texture that we have over here. So this is exactly with this vertex and fragment file and this shader material over here, we will be doing exactly what we did with mesh basic material and texture mapping over here. So if I save it and go back over here, we shouldn't see any difference, and we don't. So as you can see here, we still have our images and basically our textures on top of the geometries, and everything works as it was working before. But now we have the option of, for example, hover over and then pass that hover state to our vertex and fragment files, and then kind of like manipulate. For example, what we're gonna do is manipulate this texture over here. So let's see. One thing we need to keep in mind here is that my HTML elements, my content over here is on top of my canvas. If we look at this canvas that I have a z index of -1. So as I hover over here, you can see I'm selecting my HTML elements. In fact, if I had given this like a +1, then if I had hovered over, I could only select my canvas. I couldn't like select any of my HTML elements because the canvas was on top. And the reason I have this at like behind my HTML stuff is because now I can define an event listener, for example a mouse enter and mouse out on my actual HTML element, image element, and then use that to manipulate the WebGL image, because the positions are exactly the same. So if I'm hovering over my HTML element, I'm sure that I am actually also hovering on my WebGL geometry over here. You could like bring this whole thing on top, but then you have to use ray casting and that kind of fun stuff to detect mouse hover, so that would require more work. But with what I have here, all I need for each image inside my map function over here, I can just add a couple event listeners. First of all, I can actually add my hover state as a uniform. Originally I'm not hovering over the image, so the value is 0. With the event listeners that I have over here, mouse enter and mouse out on each image, again these are the actual HTML images, so I'm adding event listener on them, and since they are exactly at the same location or position of the WebGL geometries, then if I hover over my HTML elements, it's like I'm hovering over my WebGL objects over there. So all I'm doing here, a mouse enter, I'm changing the value for this uHover state to 1, and then on mouse out, I'm changing that back to 0. You can play with the ease. We'll see how this looks in a sec, but make sure to play with this ease in as well. So I'm gonna save it right now. Now we have to go grab that hover state over here, and then let's just store that in another variable like x. It's gonna be a float obviously because it's from 0 to 1, and then we can just go crazy here, whatever you want to do. The easiest thing I can think of is just like multiplying the p-value over here by x, and that's gonna manipulate our texture. So this is how we mapped our texture on our geometry. Right now with UV of 0 everywhere, we're basically gonna be only kind of like zooming in the bottom left corner of the image. So if I refresh, you see like if I hover over, it kind of like zooms back out, but when I'm not hovering, it kind of is zoomed in over here. Same for the other images. So you can see we can like do this kind of cool hover effects. This is probably not what you want, or maybe you want this. This is cool. Now it's just like you can play with it. You can do the opposite way. You can do 1 minus x. That means like when you hover, it's gonna just like zoom in that bottom left corner, and in the original stage it's just gonna be as it was originally. So like here it's as it was. When I hover over, it zooms in. And again, this also is affected by the easing that we had here, so you can play with that. You can get like crazy. You can use some mixed like functions, mixed functions, smooth step, all those things. Let's see, for example, I'm now going to use a mix function. So I'm going to add this mix function over here, and this is basically going to mix the two things that I just did over here, like with the p multiplied by 1 minus 1x and p multiplied by x. So I'm just gonna comment these two out, and then I'll have my GL frag color equal to that mixed value. Don't forget the semicolon at the end, and let's check it out. Now you can like do a lot of other things here. Just play with it, change these numbers. Right now I'm just keeping it very simple. See, like this is a hover effect that you'll see with the mix function that I showed you. We can kind of use other stuff, like we can use smooth step. I have another effect over here, like we can use I probably found it somewhere online on another video or something. You can like use this X over here, use smooth step, and let's check that one out. And then now this is gonna be like this, kind of like hover effect. So again, you have a lot of options here. Just play with it. Whatever you want to, you can kind of achieve using like this fragments over here. And you might be able to do stuff with the vertex file as well. One thing that you could do using scroll trigger over here, you will actually have access to the scroll speed as well, so you can manipulate the vertices kind of as you scroll. So that's kind of cool thing. For example, this is another website that I built, and in there if I go over here in this section, you can see I have some hover effects over here on these images, and keep looking at the bottom. Like as I scroll, you can see like there is a cool effect there that is using like the scroll speed and kind of like playing with the vertices, the location of vertices. So that's like the kind of thing that you can also do. Back to what we have here, make sure to again play with these numbers over here, and I love to see what you've done. go on our late night coders community and show your work, whatever you've done. Join there, and then I'd be glad to share those things. You can also use Twitter and showcase things that you do with others, so feel free to spread the knowledge and the joy. So thanks a lot, everyone. If you liked the video, please make sure to hit the like button below, and don't forget to subscribe to the channel, turn the notification bell on, and I'll see you guys soon.